So this video is going to be looking a little bit at finding the GCF, which remember stands for greatest common factor, for expressions with variables. So rather than just pulling the GCF out of something like 20 and 30, what if they were variables? So we'll look at an example with this. Let's say if we had to find the GCF of 20x and 30x. Okay, so if we're trying to find that, I'm gonna use the two methods, method 2 and method 3. So if you look at my other videos, there's one with prime factorization, and there's another called upside down half birthday cake, and both of those can be successful and can work really well here. The listing is a little bit more tricky, so we're just gonna use these two methods. So I'm gonna start with the upside down half birthday cake method. So remember, for that method, you're gonna write down your two things. So we have 20x and we have 30x. And I'm going to draw a line underneath, and I'm going to think about what can I factor out of that? What can I divide out? So usually if you're just looking at the numbers, you're thinking, what can I divide both those by? But we can see that there's a variable there too. Now in class today, I was talking a little bit about this, and so I'm going to just put this sort of on the paper on the side. But if you had, for instance, the number 20 divided by 2, times 2 divided by 2, that's going to equal 20, right? Times 2 divided by 2, they cancel each other out. If I had 20 times 5 divided by 5, that would result in 20. If I have 20 times x divided by x, no matter what number I put in here, I'm still going to get 20. So we want to think about sort of this possibility. If I'm dividing by, so this 20x means 20 times x. If I was to divide out an x, that would leave me with 20. So this is 20 times x divided by x. That's going to leave me 20 right there. So I would write 20. 30x divided by x would leave me with 30. Okay, again, it cancels. We divided out that. So now we're going to draw the second layer. Now I can just take care of it like numbers. It looks just like the ones that we were doing the other day. So I'm going to pull 2 out first. That gives me 10 and 15. Then I'm going to factor again, and I'm going to get 5, and that's going to leave me with 2 and 3. And at this point in time, there's nothing else I can factor out. So then I just circle the numbers on the left, multiply those. 2 times 5 times x. That's going to give me 10x is my GCF. Okay. We could also do this using the other method, which was the prime factorization method. So I'm just going to draw a little line right here. Now with prime factorization, we're going to list both of our things. We have 20x and 30x, and we're going to split those up. Now the first thing that when we split them up, usually we split up the number, but we're going to split the variables apart from the number for both of these. So I'm going to write this as 20 and x and 30 and x. Remember, when the coefficient or the number is touching the variable, that means multiplication. So now that I've got that, I have x's right here. Now, I can't really divide these anymore. In my past video, we talked about how you circle the primes. And you circle the primes because that means there's no more factoring that you can do. There's no more factoring that I can do once I get to a single variable. So I'm going to circle those. I don't know what x is. I will probably never know what x is. So I'm just going to stop there because I can't do it anymore. And then I just split up the numbers like we did before. So I could say 2 and 10, circle the 2 because it's prime. 2 and 5, circle those because they're prime. Same thing, I can do 3 and 10, circle the 3 because it's prime, and then 2 and 5, circle those. And then I add it to when we list them out. So I'm going to have 20x, and I just list out everything that's circled. 2, 2, 5, and x. I'm writing them in order. And then I'm going to do the same thing with 30x underneath. And that is 2, 3, 5, and x. So I'd write 2, 3, 5, and x. And then I just look for what they have in common. Okay, and I'm going to put a loop around those. So I have a loop around the 2's there, a loop around the 5's there, and a loop around the x's there. Again, if this is feeling a little confusing to you, watch the past video about prime factorization. But now we've got 3 loops or 3 circles. And so we're going to multiply 3 things together. So 2 times 5 times x, which is going to give us 10x as our GCF again. Okay, so we can see both of these methods would work when we have a variable. Now, sometimes though, you're going to have another situation, and that is that you're going to have maybe something like with a square in it. Okay, so I'm going to put another piece of paper here just so we can do this. Let's say we had a problem like 30, we'll make it a little bit more complicated. If you had something like 30x squared y and then 60xy squared, and you had to find the GCF, the greatest factor, the biggest number that you could take out of both of these algebraic expressions. So let's start with this time let's start with the prime factorization. So I'm going to split these up, and I'm going to split them up again. Take out the number and the variables, separate them. So we've got 30 and then x squared y. On this side we'll have 60 and then xy squared. Now I'm going to split up the variables more. So I can say x squared y means x squared times y. I've gotten as far as I can with that variable. This x squared, I'm going to split because x squared means x times x. And I have gotten as far as I can go with the variables. I'm going to do the same thing on this other side. We have x and y squared. Circle the x. We have y and y. Circle those. And then we do the numbers like we did before. Okay, we have 6 and 10. Split those up to 2 and 3. We have primes. 2 and 5. We have primes. So we can see we've got a lot of circles going on. We're keeping everything spread out and neat. And we've got 30. We could do 3 and 10. And then 2 and 5. Then we list them out just like before. Okay, so I have 30x squared y equals 2, 3, 5, x, and y. 60xy squared equals 2, 2,